Hello, this is video number 5 and I'll be talking about significant figures. So let's say that you are in lab class. This is very applicable for labs. And you're making a measurement. Let's say you're measuring the length of your hands with a meter stick. And you say that your hand measures 9.3246214 centimeters. So is somebody going to take you seriously with that number? Are you confident that you knew that number that precisely? So the idea is that when you are giving a measurement, the result of your measurements, that you only want to provide as many digits as you're confident with. So in this slide here, in these few slides, what we're going to discuss is when you do provide a measurement or number, then how many of those digits are significant? And then also when you deal with calculations, how many significant figures should you keep? So this example here is another one to show you kind of what we mean by significant figures. Here it's more with a calculation that it says how many gallons of gas does a car use to travel 42 miles if the car gets 26 miles per gallon? So to calculate this, you would just do 42 miles divided by 26 miles per gallon to get 1.61538 gallons. But when you are writing down the result of this calculation here, you're not going to want to keep that many decimal places because you're not comfortable with all of those numbers. And just for your reference here, I give you an idea of what each of these are worth. So 0.6 here is a little more than half a gallon, so you're comfortable with that number. But if you go down to the 0.00008 gallons, that's only a third of a drop. There's no way that you know whether or not you use that 1/3 of a drop or not. So when you're doing calculations and then you're giving answers here, you don't want to keep too many digits unless you really are confident that you know those numbers were there for sure. So when we're looking at sig figs, it's one that's reliably known, one that we're confident with. This is especially applicable when you're taking measurements. And it gives you, indicates the precision of your tool, right? So this is back to the example about measuring your hand with a meter stick. If you measure your hand with a meter stick, you might say something measured 30.35 centimeters. Well, that wouldn't be your hand, but that would just be a measurement. You wouldn't measure something with a meter stick and say it was 30.356427. You would need a tool that could make more precise measurements. So when you're giving a number, then how many of those digits are significant? So here we're looking at the rules. So if it's a non-zero digit, that means it's significant. If it's a 0 and it's between other non-zero digits, then it's significant. And then if it's a 0 and it's after the decimal point and it's also after another sig fig. So it has to follow both of these rules for this rule to be applicable here. So let's see how we use these rules. I have a lot of examples on the next slide. So example A, these are all non-zero, so they're all significant, so you'd have 3 sig figs. The next one, the non-zero numbers are all significant, and then the zeros, they satisfied rule number 2 that said they were between other non-zero digits. So that means they're significant as well, and that's 5 sig figs. And then example C, these zeros are also significant. They satisfy rule number 3 that says that they're after the decimal point and they're also after another sig fig. So these two zeros are after a decimal and they're also after a sig fig. So you have 4 sig figs here. Now the next one, it only has 2 sig figs, the 2 and the 0 here. This 0 is after the decimal and after another sig fig. However, the zeros that come before are not significant. Even though these two here are after a decimal place, they're not after another sig fig. Example E would have 2 sig figs because the 0 and the 2 are significant, satisfying rule number 1 and rule number 3. The scientific notation, you don't take that into account when counting the sig figs. And finally, the example F here only has 2 sig figs as well. These zeros are not after a decimal place, they're not between other sig figs, so they're not significant. So you might be wondering, well, if I have these zeros here or if I don't have them, that makes a big difference in my number. But that's not what sig figs is all about, because sig figs tell you more about the precision of your measurement. So if you have 2500, you could rewrite that as 2.5 times 10 to the third liters. And then you can see that only the 2 and the 5 are significant, that these just increase your power of 10, or in the case of example D here, they make your number smaller, these zeros, but they have nothing to do with the precision of your number and which of the digits that you are confident with in your measurement. So the last thing we want to do here is know how many sig figs do we keep when we're doing calculations. So there are 2 rules here. When you're multiplying or dividing, then you want to look at each number and look at which number has the least number of sig figs, and then your answer will have that many sig figs. So in this example here, 98.6 centimeters times 55 centimeters. So the calculator will give you 5,423 centimeters squared. But if you look at each number individually, this one has 3 sig figs, the 98.6, and the 55 only has 2 sig figs. That means you only want to keep 2 sig figs in your answer, so you're going to have to round your number, and the 2 here is less than 5, so it's going to round down. So you're going to round to 5,400 centimeters squared. If the 2 had been a 5 or above, then you would have rounded up to 5,500 centimeters squared. And then the rule with addition and subtraction is that you actually look at the number of decimal places. And the number that has the least number of decimal places, that's how many decimal places that you want to keep in your answer. So this 12.25 has 2 decimal places, 0.6 has 1 decimal place, 44 has no decimal places. So that means that your answer will have 0 decimal places. That's the least number of decimal places. So 56.85, you're going to have to round that up, that because of the 8, and that will round up to 57 meters, a number with no decimal places. So those are the rules for dealing with calculations when you're multiplying, dividing, adding, or subtracting numbers. And I have one final example here. So express your answer with the correct number of sig figs. So the first one here, you want to put it in your calculator. When you put it in your calculator, you're going to get 5.76563 times 10 to the negative 8. And one of the meters cancels out, you still have meters left over. So if you need to answer this for the correct number of sig figs, this is multiplication division. So you look at the numbers, the one that has the least number of sig figs. You have 2 numbers that have 2 sig figs, so you want 2 sig figs in your answer. So this 7 is going to round up due to the 6 here, and we'll have 5.8 times 10 to negative 8 meters. Another reason why I have this example A here is because I strongly encourage you to plug this into your calculator just to make sure you know how to use the calculator. A lot of times students don't get this answer because they're plugging in something incorrectly. And one shortcut with plugging in numbers with scientific notation, the way that I would plug this into my calculator, the first number, for example, instead of writing times 10 to a certain power, there's a key that in a lot of calculators, it looks like a double E sign. And then if you just put that stands for times 10 to the. And then that's all you have to plug in your calculator, and then you can multiply by the next one, and then you don't have to worry about all the different parentheses that you do have to worry about if you enter the number as is. And then you divide by 3.2 and this key and then 5, and then you should get this answer. The last example here is a simple addition problem. If you're adding 93.46 centimeters and 135.3 centimeters, we're looking at the number of decimal places. Keep one decimal place because that's the least number of decimal places. So although your calculator will give you 228.76, you want to round that to one decimal place, and that's going to round to 228.8 centimeters. So that's the end of this video. So just a recap of what we talked about. How do we know when numbers are significant? All non-zero digits are significant. Their zeros have to either be between other numbers or they have to be after a decimal and another sig fig. And when you're doing calculations and writing your answer, you want to keep a number that has look at all your numbers and look at how many sig figs and find the least sig figs and have that many sig figs in your answer. Sorry, that was long. And if you're adding or subtracting, just keep the number of decimal places that is the smallest. And one last thing, if you're in my class, I'm not really picky with sig figs. I will test you on it in a few problems, but after that, when we get to the later chapters, as long as you keep 3 sig figs in your final answer, you'll be okay. What you just really have to be careful about is that you don't round until the very end. So whenever you're doing intermediate calculations, leave as many digits as possible and only round the final answer.